Imagine a colossal orchestra composed of an infinite number of planets, stars, and moons that work together as a single unit. However, there is just one, a part of the grand symphony that has long puzzled cosmologists: exoplanets. Exoplanets are ordinary worlds outside of our own solar system, hidden away in the Milky Way. It may astound you to realize that among the numerous astronomical objects out there, some exoplanets bear an uncanny resemblance to Earth. This revelation sets the stage for a surprising twist, much like something out of a thrilling science fiction story. Thrill-seeking scientists utilizing the James Webb Space Telescope captured something extraordinary from Proxima b, a strange anomaly that reverberated across academic discussions and social media. It was dubbed a potential technosignature. This complex electromagnetic radiation was so intricately arranged that it increased the likelihood of an advanced civilization existing in the region. Humanity's collective heartbeat seemed to freeze at the peak of this discovery, one that could forever alter our perception of existence. Might this signal be the definitive proof that we are not alone in the universe? But just as quickly as it appeared, the signal disappeared without a trace, leaving behind not only an overwhelming silence, but also a complex web of unanswered questions and brewing theories. Was this merely a transient cosmic anomaly, a random alignment of celestial events, or something far more deliberate? A coded message? Or even a sign of an unsettling cosmic presence? The singular mission cast a shadow of mystery over Proxima b, sparking intense debates and speculation. Was this just a fleeting oddity, or part of a vastly more intricate, infinite story than we can imagine? But wait, our cosmic tale isn't complete. The ink on this narrative has not dried, and new chapters are still being written. At this very moment, it is not just ordinary researchers, but Harvard experts who are leading a transformation in the way we approach the search for extraterrestrial life. Their focus goes beyond just analyzing the signs and anomalies we've seen so far. They're enhancing the game. The James Webb Space Telescope is being turned into a gigantic night vision tool, specifically designed to search for artificial light sources in both dark and illuminated regions of distant worlds. We're considering intriguing possibilities, such as detecting Earth-like urban centers glowing in the dark, like radiant cities illuminating the vast cosmic oceans. As we continue to unveil the mysteries of the universe, the quest for extraterrestrial life takes on an entirely new dimension. Beyond Proxima b's immediate intrigue, our monumental search delves deeper into the vast and enigmatic realms of space. This pursuit is driven not only by technological advancements, but by an insatiable curiosity regarding our place in the universe. Ongoing breakthroughs in cosmology and space exploration have led to the identification of numerous exoplanets that could potentially harbor life. Tools like the James Webb Space Telescope, JWST, and ground-based observatories have vastly improved our ability to detect and study these distant worlds. One particularly fascinating area of research is the search for biosignatures, indicators of life. These could include atmospheric gases such as methane or carbon dioxide, which under specific conditions could point to biological processes. The JWST's capabilities go beyond straightforward detection. Its advanced instruments allow for precise measurements of the atmospheric composition of exoplanets. By studying starlight that filters through an exoplanet's atmosphere, scientists can identify chemical markers linked to life. For instance, the presence of water vapor, together with molecules like oxygen and ozone, could indicate conditions conducive to life. Another promising avenue of research involves examining the environments of these faraway worlds. In addition to biosignatures, the idea of technosignatures, traces of advanced civilizations detectable through artificial structures or technology, has gained traction. These could manifest as engineered megastructures like Dyson spheres, designed to capture the energy of stars, or as unusual radio emissions. As we refine our observational techniques, the search for technosignatures could reveal extraterrestrial intelligence. Beyond technological innovations, global collaborations are essential to the search for extraterrestrial life. Partnerships between space agencies, research institutions, and private enterprises enhance our capacity to explore the cosmos. Missions to Mars and other celestial bodies, for example, are multinational efforts, pooling resources and the ability to reach common objectives. Public engagement and education play a critical role in this endeavor. The excitement surrounding space exploration inspires future generations of scientists and engineers. Outreach programs and educational initiatives foster interest in STEM fields and encourage young people to pursue careers in space science. The development of new technologies further enhances our understanding of the universe. Advancements in telescope design, data processing models, and computational power enhance our ability to find and analyze far-off exoplanets. Cutting-edge space telescopes such as the Extremely Large Telescope, YELT, and the Habitable Exoplanet Observatory, HABEX, are set to provide additional, more in-depth observations, giving us greater understanding of the potential habitability of distant worlds. With every discovery, new inquiries and areas to investigate emerge. The search for extraterrestrial life is not just about locating alien civilizations. It's about understanding the origins and potential diversity of life across the cosmos. It challenges our perception of the world and deepens our understanding of what it means to be alive. In conclusion, the exploration of exoplanets and the search for extraterrestrial life are dynamic, evolving fields. With each advancement, we draw closer to answering some of the most fundamental concerns of humanity. As we keep exploring the universe, the possibilities for discovering new forms of life and comprehending our position in the cosmos remain endless and tantalizingly close. It's possible that our planet's celestial twin, Proxima b, situated just 4.2 light-years away, continues to be one of the most fascinating cosmic puzzles. The James Webb Space Telescope is transforming our quest for extraterrestrial life, enhancing our understanding of these cosmic enigmas. Imagine a moment when your thoughts travel across the vast expanse of our galaxy, the Milky Way, which contains more than a quadrillion exoplanets. That's a 1 followed by 15 zeros. To put this in perspective, if each of these exoplanets were the size of a grain of sand, we would not only occupy the Grand Canyon, we'd have enough to establish a new landmark on Earth's version of the Grand Canyon 2.0. What is most important when traveling a great distance? The fact that approximately 20% of these celestial bodies have been identified as Earth-like in terms of their location and environmental characteristics. That means we have a 1 in 5 chance of finding a twin to our planet. The narrative does not end there. Along with these planets, there might be an additional 4 billion moons. But before we start dreaming of traveling to Proxima b, we need to consider its peculiarities. For one, Proxima b orbits a red dwarf star, Proxima Centauri, which, despite being the closest star to our solar system, behaves very differently from our sun. Red dwarfs are known for their volatility, frequently emitting powerful solar flares that could potentially strip away a planet's atmosphere or bombard it with harmful radiation. This raises a crucial question. Could life truly survive under such extreme conditions? Another point of concern is Proxima b's orbital characteristics. It is likely tidally locked, meaning one side of the planet permanently faces its star, basking in eternal daylight, while the other remains cloaked in perpetual darkness. This could create extreme temperature differences between the two hemispheres, posing challenges for the development and sustainability of life as we know it. However, scientists propose that if Proxima b possesses a substantial atmosphere or an ocean, heat might be distributed more evenly, potentially allowing for habitable zones, especially around the terminator line, the boundary between day and night. These complex conditions make Proxima b a captivating case study for astrobiology. Even if it doesn't host life now, understanding its climate and geology could teach us how planets evolve in high-radiation environments. Moreover, it could reveal what ingredients are truly necessary for life to thrive. As our telescopes grow more powerful and our analytical methods more refined, the excitement builds, not just for what we might discover on Proxima b, but for what it represents, a testbed for our deepest questions about life, the universe, and our place within it. This is only the beginning. The coming decades promise new missions, more sensitive instruments, and perhaps even interstellar probes. Concepts like Breakthrough Starshot, a project aiming to send light-powered nanocrafts to Alpha Centauri, could turn science fiction into science fact. These miniature explorers could, within our lifetimes, deliver data straight from the Proxima system. Imagine receiving images from the surface of a distant planet, a rocky terrain under a foreign sky, or perhaps a glimmer of light that shouldn't be there. Something artificial. Something alive. We are on the precipice of a new era, one where the questions once confined to philosophical pondering may finally have answers grounded in evidence. Proxima b might not just be another planet. It could be the first page in a new chapter of human history, the one where we find that we are not alone. Just one day you've provided captivating exoplanet, an astonishing 11 Earth days. Or expand on a specific sunsets that linger for hours. Feel free to let me know creating what mesmerizing views that photographers would dream of capturing. While this might sound idyllic, it also brings up significant challenges. How would the environment, habitability, and human biorhythms adapt to the cycles of light and darkness on Proxima b? Would we need to eat more frequently? Go to sleep 3 or 4 times a day? Could we live the same way we do here on Earth? Fundamental aspects of life, as we know it, would be put to the test. Yet, in some ways, it would feel strangely similar. Nature, in its strikingly abnormal fashion, presents us with a puzzle wrapped in a mystery, forcing us to reconsider what could make a planet truly habitable. How can we gather reliable and accurate information about a world we've never been to? Enter the James Webb Space Telescope. It's not just a telescope, it's a sophisticated laboratory for research in the vacuum of space. Thanks to its cutting-edge technology, scientists can not only look at distant planets, but also study them using a powerful array of scientific instruments. With advanced spectrographs, the JWST can analyze the light emitted or reflected by faraway planets. Every element in a planet's atmosphere absorbs or emits light at a particular wavelength. By concentrating on these light patterns, scientists can conduct a sort of remote biopsy of these celestial bodies, measuring air pressure, density, and even detecting compounds essential for life, such as oxygen, organic carbon, and water. This isn't just cosmology, it's space forensic science. Rather than merely waiting passively for clues, we actively search for them, investigating the atoms and molecules that compose these distant worlds. The JWST isn't merely an eye in the sky, it's a highly specialized laboratory, a cosmic investigator. It empowers us to turn theories and speculations into verified scientific findings, transforming our understanding of what could exist beyond our pale blue dot. Just when you think you've uncovered the deepest layers of this vast cosmic tapestry, the adventure is only beginning. As we stand on the edge of groundbreaking discoveries, the James Webb Space Telescope serves as a beacon of hope and innovation. Its advanced instruments are designed to explore the intricacies of distant worlds, revealing facets of the universe previously beyond our reach. Its ability to analyze exoplanet atmospheres allows us to extend our exploration to the farthest corners of space, providing insights beyond the basic question of whether life could exist on other planets, to how it might manifest under different conditions. One particularly thrilling aspect of this research is the potential to find biomarkers on exoplanets. Environments with biosignatures, like specific atmospheric gases or chemical compositions, could be signs of biological processes. For example, detecting a mix of gases like methane and oxygen might indicate biological activity, as these substances often result from Earth's life processes. The JWST's advanced spectrographs are able to identify these subtle signatures, providing a new window into the possibility of life beyond the solar system. The quest for exoplanets has led to the discovery of diverse planetary systems, each with its own unique characteristics. A few exoplanets have even been discovered in binary star systems, where 2 stars orbit each other, creating intricate gravitational environments. Others orbit red dwarf stars, cooler and less luminous than our Sun, yet still capable of sustaining habitable zones. The discovery of such unique systems opens up new possibilities for where life could exist, even under conditions we might not traditionally associate with habitability. Planets orbiting red dwarfs, which are far more common than Sun-like stars, could potentially offer stable environments capable of supporting life, despite their stars' lower brightness and increased variability. This expanding diversity in planetary systems suggests that habitability might not be confined to the familiar parameters of our solar system. One of the most exciting aspects of this is the potential to learn from radically different forms of life that might not resemble life as we know it on Earth. Traditional models of life often center around the need for water, carbon, and oxygen. But new discoveries could challenge these assumptions. While the search for biosignatures is often focused on familiar sustaining conditions, researchers are becoming more receptive to the idea that life could thrive in entirely unexpected environments. Whether in the gas giants, under the icy crusts of distant moons, or in extreme conditions not typically considered conducive to life. Moreover, advancements in technology are transforming our ability to identify and interpret even the tiniest traces of life, or advanced technology, in distant worlds. Instruments like the JWST can help us locate the chemical fingerprints of life, whether through gases generated by biological processes or synthetic pollutants that might indicate the presence of intelligent life. By observing and analyzing the atmospheres of exoplanets in detail, we can assess whether they exhibit signs of biological activity or advanced civilizations, furthering our definition of what it means for a world to be habitable. This heightened sensitivity to life and its signatures is not just a scientific pursuit, it's a philosophical one. The implications of discovering life elsewhere in the universe are profound. It would make it harder to claim Earth is unique and would redefine humanity's place in the cosmos. Finding life, or evidence of an advanced civilization, would not only answer long-standing questions about our own origins, but could also suggest that life exists in some form across vast stretches of space and time. The broader societal impact is exciting. Based on such discoveries, the notion that we could eventually contact or locate evidence of intelligent life beyond Earth stirs the imagination and propels a new era of exploration. This drives funding and research, attracts a new generation of scientists, and fosters international collaboration as we strive toward a shared cosmic goal. The questions we raise today about life, our place in the universe, and the nature of intelligence are the same questions that will shape the direction of future space exploration and technological development. As we continue to expand our exploration of space, through both manned and unmanned missions, we must also prepare for the new challenges that will arise. As technology evolves, so too will the methods we use to search for life. We'll need to develop more powerful and precise tools to detect life in ways we can't yet fully imagine. The journey of discovery is ongoing. With each new technological leap, we unlock further layers of cosmic knowledge. The search for life on other planets isn't just about finding organisms that look like us. It's about exploring the extensive range of possibilities that exist in the universe. As we push the boundaries of space exploration and technological innovation, we're not just observing the cosmos, we're reimagining our place within it. And in doing so, we may soon discover that there is far more life in the universe, more numerous and diverse than we ever imagined, challenging us to rethink everything we know about how it all began, about life and the nature of existence. This unfolding cosmic narrative is not just a journey through space, but a journey of understanding, of ourselves, our origins, and our potential future. With every planet we study, every light spectrum we analyze, we peel back another layer of the great unknown. We are no longer just stargazers, marveling at the night sky from a distance. We are explorers, scientists, and storytellers, armed with the tools to decode the universe's ancient messages. The James Webb Space Telescope, along with upcoming missions like the Nancy Grace Roman Space Telescope and potential next-generation observatories, represent humanity's growing capacity to transform wonder into knowledge. And with that knowledge comes responsibility. As we edge closer to finding life beyond Earth, we must consider the ethical implications of contact, whether through microbial discoveries or evidence of intelligent civilizations. What does it mean to engage with another form of life? How do we approach such a revelation with humility, care, and curiosity instead of conquest or fear? We will also face the challenge of communication. How do we interpret signs of life so different from our own? Would we even recognize intelligence if it doesn't mirror ours? These are not just scientific questions. They are philosophical, cultural, and even spiritual. They ask us to think beyond borders, species, and centuries. They require a unity of vision that transcends the present moment, urging us to act as caretakers not only of Earth, but of all life, wherever it may be found. Our pursuit of life in the universe is ultimately a reflection of our own search for meaning. It reveals our deepest desires, to connect, to understand, to belong to something greater. So, as we continue to map the stars, decode the atmospheres of alien worlds, and send our machines further into the void, we must keep asking the biggest questions. Who are we in this vast expanse? What are we meant to find? And what will we become once we do? Because the story of the universe is not complete without us. And perhaps someday soon, we will learn that we were never truly alone. We were just waiting to listen.